Hello everyone, here in this video we want to talk about expansion of a solid with respect to temperature. We shall understand that when temperature is raised, a solid could expand along its length, area and volume, one-dimensional, two-dimensional and three-dimensional. To measure the expansion along the length called linear expansion, we have a term called coefficient of linear expansion. As we have defined in the previous video, coefficient of linear expansion is ratio of increase in the length of the solid to its original length per 1 degree centigrade rise in temperature, T2 minus T1 per degree centigrade. Similarly, we have areal expansion for a solid is defined as ratio of increase in the area to its original area per 1 degree centigrade rise in temperature. Similarly, to measure volume expansion, we have coefficient of volume expansion defined as ratio of increase in the volume to its original volume per 1 degree centigrade rise in temperature. Having defined these three things in the previous video, next we want to find a relation between these three, how they are related to each other. Well, to do that, to find a relation, let us consider a cube of unit dimensions. What I mean by unit dimensions, its length is 1 meter, its breadth is 1 meter, its height or thickness is also 1 meter. It's a cube. So if I have to draw a diagram, I can draw it like this. It's a cube having unit dimensions in all the way. We are raising the temperature by T2 minus T1, increasing the temperature by 1 degree centigrade. What happens to these three things in that case? Let us try to identify. We know alpha is defined as L2 minus L1 by L1 of delta T. When you cross multiply, L2 minus L1 is alpha L1 delta T. Take that L1 that side, L1 plus alpha L1 delta T. So L2 equal to L1 common, 1 plus alpha delta T. That's what we have find is final length in terms of initial length and rise in temperature. Let us substitute what we have identified in our case. Yeah, what happens? L2 equal to, we have got a formula L1 of 1 plus alpha delta T. What is L1? We have considered a cube of unit dimension. So L1 is 1 meter. 1 plus alpha. We have raised the temperature also by only 1 degree centigrade. So delta T is also 1. So L2 is equal to 1 plus alpha meter. Similarly, I can find out A2. A2 as what? We can write A1 of 1 plus beta delta T. We'll write that later anyway. We'll try to find a relation between alpha and beta. Let us take the definition of beta, as we have defined beta as A2 minus A1 by A1 into delta T. So A2 can be written like, I can say L2 square minus L1 square by L1 square of delta T, because it's a cube, area is the square of the length. But I know L2 already I have found as 1 plus alpha whole square minus L1 square is 1 square by 1 square. Change in temperature is only 1 degree centigrade. This is A plus B whole square, A square plus B square plus 2AB Yeah. So -1 and +1 will cancel. What I got beta as alpha square plus 2 alpha. That's the relation between beta and alpha. But I want you to tell you one thing. This alpha is small. For example, for iron it is 11 into 10 power minus 6. That implies alpha square becomes 121 into 10 power minus 12, which is very small for our mathematical calculations that we make in +1 and +2 stage. So alpha square becomes even very small and we can ignore it. That can be ignored. If that is ignored, I can get beta as, when you ignore this alpha square, 2 alpha itself. So you will get beta is equal to 2 alpha. What's the meaning of that beta equal to 2 alpha is expansion along the area is double to the expansion along the length. Similarly, not only relation between alpha and beta, we can also find a relation between alpha and gamma volume expansion by taking the definition of gamma as ratio of increase in the volume to its original volume per 1 degree centigrade rise in temperature. In the place of V2, I can write 1 plus alpha whole cube, L2 cube, where L2 equal to 1 plus alpha. V1 as L1 cube. L1 is 1 itself. 1 cube delta T is also 1. This is A plus B whole cube, so A cube plus B cube plus 3A square B plus 3AB square minus 1 by 1. This 1 and 1 can be cancelled. It implies you got gamma as alpha cube plus 3 alpha square plus 3 alpha. And the same concept can be continued here. What is that? Alpha is small, that implies 3 alpha square and alpha cube becomes very small and they can be ignored for a normal regular calculations that we are making. That implies you can get gamma as, when you ignore these two, the remaining term is equal to 3 alpha. So you got a relation. So if you have to write an equation that what is the ratio of linear areal and volume expansion coefficients of a solid, alpha is to beta is to gamma is, you call it alpha as alpha. In the place of beta, I can write 2 alpha. In the place of gamma, I can write 3 alpha. Alpha can be cancelled. So the ratio is 1 is to 2 is to 3. So the linear, areal and volume expansion of a solid coefficients are in the ratio of 1 is to 2 is to 3, which says that if a solid expands its length by one value, along area it expands by 2 values, and along volume it expands by 3 values. That's the important observation that I want you to understand, right? Thank you for watching. Thank you.